Okay, hi everyone. So let's talk about point discontinuity today, and it actually expands upon rational functions, because I have f of x equals a of x over b of x, where let's look at our conditions. B of x cannot equal 0, and x minus c is a factor of a of x and b of x, so it's a factor of both the polynomials a of x and b of x, of our numerator and denominator. Okay, and x minus c being that this is after you factor down a of x and b of x, and then they have a common factor, which is x minus c. So when they have that common factor, and we cancel them out, correct? Actually, what happens is that means that at that point, x equals c, we have a point discontinuity. Okay? Basically, your graph kind of stops at that point, and then it continues after that point. Alright, so let's look at an example. I have f of x is equal to x squared minus 4 over x minus 2. Okay, well, I can factor x squared minus 4, okay, which becomes x minus 2 and x plus 2 by the difference of squares. I can do that. And this is all over x minus 2. Look, so our numerator and our denominator, we have a common factor, and that's x minus 2. So I can cancel, and usually what we do, we factor them out. We take them out. We cancel them out. You know, it's like we're just so desperate to get rid of factors. But okay, anyways, and then we're left with x plus 2, and this is actually what we plot on our graph. So since this x plus 2 is actually what we plot on our graph, this is like our x minus c, correct? So this is our c value. Alright, so c is equal to 2 in this instance, because this is our, x minus c. Let me go ahead and write it down below instead. This is our x minus c, and c is equal to a positive number, so c is equal to 2. Right, so that's why I have c equal to 2. So this is where our point discontinuity is. So basically what we would say is that we have a point discontinuity at 2. Alright, graph y equals x squared minus 4 divided by x minus 2. This is our rational function, and I left it as such purposely. Because if I just did, we got y equals x plus 2, correct? But then it's just going to graph y equals x plus 2. So basically your graph is, or whatever, computer or graphing calculator you put, if you just put y equals x plus 2 in there, it's going to plot every single point. But if you leave it as its rational function, then look what happens, right? I go up to 2. We said our point discontinuity was at 2. That's what we calculated. So I go up at 2. Let's see if I get this right. Yes, I got it. 2 is undefined. You see, it jumps that point, and then it goes off to every other point. You see how every other point is now like it's a colored in bubble. All right, so it's all included. But if I go back to the 2, right, it's not included. You see how it has an open circle? An open circle means that it's not included. And that is our point discontinuity at this rational function.